Hi, everyone. Welcome to our second Fireside chat on teaching practical machine learning with Goku Mohandas and myself, Hugo Bowne-Anderson. We'll get started in a couple of minutes, but I just thought, as you're joining now, perhaps you could introduce yourself in the chat and let us know what your interests in machine learning are and what you're excited to hear about today. It looks like we have someone called the Wolf of Wall Street here. That's incredibly exciting. Hi, Wolf. We have OP1 Kenobi here as well. And we have Ataliba Miguel from Angola. Oh, fascinating. Wolf of Wall Street has said, I'm totally new to machine learning, but studying neuroscience, which is a topic, I mean, health in general and the sciences are topics very close to my heart and even closer to Goku's. So that's really exciting. All right, so we'll get started in a minute, just as a few more people roll in. But if you'd like to introduce yourself in the chat and let us know about your interest in machine learning and particularly practical machine learning, it'd be great to hear why you're here today. All right, well, it is time to get started. So I'm going to share my video and stop sharing my screen. And Goku is going to join us.
Hey, Hugo.
Hey, Goku, how are you, man?
Good. Good to see you.
Likewise, it is an absolute pleasure to be talking with you today about practical machine learning and all the different types of things and evolution of things that we feel we may need to know and trying to help define, contribute to the space, which has a lot happening in it at the moment.
Oh, absolutely. I'm happy to be here. I feel like we had a version of this when we first started talking a couple months ago, and I'm very happy that we're putting this together in a more organized fashion now, because I think we got to talk for hours. So I'll try to keep today under about an hour today, though.
Well, it's interesting. We have been talking for several months, and I feel like the space has changed even in that time. So, I mean, this is one of the reasons I wanted to speak with you today publicly is we can talk about tools and techniques and all of that, but I think maybe what we need more are like ways of thinking and heuristics and approaches and mental models for what's happening. And that's something I really appreciate in your work. But before we get there, I would just like to introduce you, and you'll say a bit more yourself. But everyone, Goku Mohandas is founder of Made with ML, which is, in my humble opinion, one of the most exciting and interesting resources for lots of different people to learn about practical machine learning. In particular, one thing I'm really excited about it, or let's say two things, I'm going to limit it to two, is that you make very clear that ML is not a separate industry. I'm going to read your words. Instead, it's a powerful way of thinking about data that's not reserved for any one type of person. So you've got personas such as software engineers, college grads, data scientists, product managers in made with ML. The other thing that I do want to get to that I'm very excited about is when you start looking at ML ops, you don't begin with, hey, how do we build DAGs, right? Or how do we think about constructing pipelines and that type of stuff? You think about purpose, you think about products, system designs, the actual projects. So it's very upstream of a lot of the symptomatic concerns that people have, and that's something I'd really love to dive into. So everyone, that's one of the reasons I'm very excited to have Goku here. But Goku has also worked on machine learning and product at a large company, being Apple, a startup in the oncology space, Ciitizen, and has run his own startup in the rideshare space, being HotSpot. I will also say we are having a Q&A. Feel free to ask any questions in the chat, everyone, and we'll get to them if possible. But we are having a kind of a week-long async AMA on our community Slack afterwards. So if you ask questions there for Goku and myself, we'll jump in every now and then and answer them. So that's the Slack link in the YouTube chat, and there's a channel there called AMA Guests. So if you want to ask any questions there after the fact, that would be super cool. I also just thought to let you know, I'm Hugo Bowne-Anderson. I run developer relations at Outerbounds, and at Outerbounds we're young and somewhat stealthy, but we're just really excited to be working on infrastructure and productivity tools for data scientists that essentially allow them to focus on building models and doing science while having easy access to all the infrastructural layers. I mean, my personal, having worked in basic science research and data science for over a decade now, scientists, I think, unless they're really excited about it, shouldn't need to know all the details of compute and orchestration and infrastructure, but should be able to easily access them. So it's building tools and wisdom layers and productivity tools around these types of things that we're really excited about. We're doing it through an open source framework called Metaflow, but we're also really excited to be working on products. And I know you've been excited about Metaflow as well, Goku. So that's one of the ways.
100%. I was just going to quickly say, I don't do a lot of podcasts and interviews, but I was 100% into this because I just love talking about this stuff with people that share the same mindset. And there's not enough people talking about this. We always hear, oh, the landscape is saturated with too many tools and platforms, but it's actually the opposite. I don't think there's enough people thinking about this in the right way and then building the tools to kind of make it easier to practice those things. So that's why I'm super excited about Metaflow and Outerbounds, and met with quite a few folks on the team over the last couple of months. And yeah, super happy to be here.
Awesome. So if you're watching and you're enjoying this, definitely share it with friends and hit subscribe if you think it'll interest them as well. But without further ado, I'd love to, maybe we could set the scene by hearing about you, Goku. I'd love to know a bit about your background, perhaps with a focus on what led you to build Made with Machine Learning.
Sure. So you kind of laid out the big milestones there, but definitely I think during each of those times, I never knew what the next thing was going to be. But my background is in biology and chemistry. And I saw some folks from neuroscience watching right now. So I think it's amazing that this field and, this practice and the field of technology itself isn't just being kind of just reserved for the things that make short-term money, right? Advertising, finance, et cetera. And there's people in just amazing industries, life sciences, energy, geography, just using this to kind of accelerate everyone's respective industry. So I love that. But that's my background in the biology side. And if we have time at the end, I can talk about my main thing that I'm working on now, which is on the genomic side of things.
Right.
And I actually didn't learn how to code until I'd say the last couple of months of undergrad. And I always share that with people who say it's too late, because, now I work with people who've coded since they were 4 or 5, right? Sometimes their first language, if you will. So it's never too late for people who are thinking about, jumping into tech and specifically trying to leverage ML. In fact, there's the pros and cons. There's a lot of resources now, but, I think kind of once you weed through that noise, it is very possible to learn and learn quickly and come into this space. But like you said, I had starting backwards, I had a startup during grad school in the rideshare space. It was my first foray of applying machine learning in production. And this was 7 years ago, so it looks very different. And maybe slightly embarrassed about the systems I built back then, but I love being able to build something for a specific audience and then actually being able to maintain that over time. And some of the principles that I learned there stay true today. And I definitely tried to share that on Made with ML so others can think about it. The tools have changed. That industry actually has changed completely, ride sharing, but the principles that we used to build at that time are actually lasting. So that's something we'll touch on later. After that, unfortunately, we were on the wrong side of the market. We would predict where surge would occur for the taxi market. And at that time, Uber and Lyft actually had something very similar already brewing up, with a very, very close name actually as well. But then I went on to work at Apple, mostly NLP for almost 3 years. And at the tail end, started to come back to my domain, which is in the health space. And I had left to join the director of Apple Health Records after his younger sister passed away from cancer complication. He started a company in the oncology informatics space. And, ML, it was no one's vision that ML was going to solve everything, but it could potentially play a very crucial part in sort of reducing the amount of data that an expert would have to process. So that was kind of the gist of what we built there. I had an amazing time there. And while, the space is still growing, nothing's truly solved. I think we were able to push a very small aspect of that. And there's so many companies in that space now, which is amazing to see. But after we were acquired, I had started hearing whispers of this thing called COVID, and I didn't exactly know what I wanted to do next. I built ML systems at a large company, built it from scratch at a startup for a very specific industry, and then the startup of my own as well. And I just wanted to share kind of the commonalities across these 3 different experiences. And that's kind of where Made with ML is right now. It's sort of this basics, first principles approach to thinking about a lot of these topics. And I try to make these things hands-on as possible, because it's not enough just to read about this, but you need to be able to practice it and exercise it, and actually continue to do that over time as well. So you keep sharpening these things. But that's where we are today, or rather about 6 months ago, kind of continued to add content to Made with ML, and we can talk about kind of my focus there. But yeah, it's been kind of a crazy journey, but definitely looking back, don't regret any of it. And it's definitely all influencing what I'm working on now, and hopefully continuing to be working on.
What a wild journey, and very exciting and inspiring journey as well. I do want to kind of dive into some of the mechanics of Made with ML, but there are a couple of things first. It totally resonated with me when you said you learned to code later in life. I'm in a very similar position. I didn't really start coding until I was doing my postdoc. I'd moved from pure math to applied math, working in cell biology and biophysics. And my job was ostensibly to do mathematical modeling for the biological sciences, for cellular dynamics, actually, cytoskeletal dynamics, like mitotic spindle stuff and that type of stuff. But I was working in a biology lab with a lot of biologists who were generating gigabytes, if not more, of data a day. And I'd done some statistics and, I'd done a lot of math, right? But it became clear that I needed to figure out how to wrangle all this stuff. This was in 2011, and I discovered something that was then called the IPython notebook. And of course, we know where that journey took us. Well, that's actually how I ended up in education as well. I love doing research, but I started splitting my time between research and teaching what I called practical data science for research scientists workshops at the universities and institutes I worked at. And it became clear that I could have more impact that way. Actually, absolutely. I enjoy both the same, but the amount you mentioned noise before, and I think one way I like to think about this is we're in an information abundant landscape now, and for developers, scientists, people wanting to do research, people wanting to put things in production, we need to increase signal to noise for them, right?
Yeah, absolutely. And I think things like this podcast are going to be doing exactly that. Just really quickly, your experience it resonates, I think, with me and with so many other people. But the need to learn something is different from being forced to learn it. So I said I started learning learned to code at the end of college, but I actually took a class in high school, and it was kind of in a forced scenario. Wasn't really the mindset, just learned it to learn it, right? Or get through the course, sort of a requirement. And it really didn't connect. And then, years later, when I needed to use it for something and there was a reason behind it, I enjoyed learning it, to the point where I continued doing it even after fulfilling the immediate need. But I want to touch on that as we talk about topics today, because this whole, topic of ML and ML ops, these are just approaches to solving problems. And it's one way to solve problems. So you learn about things in the beginning to get a good understanding, but then you get into the details or explore other techniques when you need them. And there's always an explore exploit that you should kind of a mindset that you should follow. But yeah, it's just so much more fun when there's a purpose behind learning something. I think, that's how I like to operate. But yeah, it didn't feel like I was just going through a book or something.
Yeah, agreed completely. And I think that the need when you actually have something that you really want to do, and in fact, that I've worked a lot in the PyData space, and the PyData stack is very close to my heart. And I always make sure people are aware that it wasn't built for the most part by computer scientists or software engineers. Yeah. It was built by neuroscientists, astronomers, geologists, people who needed these tools. They noticed that, Fernando Perez had built IPython, that there was some cool stuff happening with matplotlib. And it's like, suddenly we can have this Swiss Army knife, essentially. But the need, my dad's retired now, but he was literature academic and writer and professor. And he, so I get quotations floating in my head. I don't even know what they're from, but I remember when growing up, he would say the threat of execution focuses the mind wonderfully. I've got and maybe Oscar Wilde or something like that. But when you need to do something, right? That's when you really zoom in. I just want to. This may be dangerous to go here so soon, but I'm ready. I'm feeling comfortable.
Let's do it.
We've mentioned machine learning in production several times. What even is that?
Yeah, let's dive right in there. I think right now, a lot of people learning this stuff in school, or maybe you're already working and you're trying to get into the topic. You see a lot of model-focused tutorials, research, and things out there, right? Where you have a task, maybe you have some kind of a toy data set, but it's this closed learning scenario where you're just applying a model to some data set and you're trying to see something like a performance or something. And you close the notebook and you say, hey, I've learned about this model. I learned how it works. I'm seeing the results on this toy data set. I've learned it. When it comes to machine learning and production, first of all, there are a lot of assets. And I like to call them assets because it's not just about data, but there's so many assets like the data, the model's weights, the performances, configurations for the different systems you're building, separating things into workflows. And then to add to all of this, these assets are not fixed. These assets are now dynamic. Your data changes, your models will change, your performances will change, your maturity in terms of what the system looks like will change as you kind of build out and you need to scale out, or you need more granular functionality. So you have assets and you have that, and these assets are dynamic. It's just so hard to learn this because there's so much in flux. And that's kind of one of the main things that I'm trying to address with Made with ML is how can we teach something so dynamic in a linear fashion? And linear is a key word here because even the processes are very cyclical. You'll notice on Made with ML, I teach testing like in the middle of the project-based course. It really doesn't belong only in the middle. Like I actually do test all the code that I even did in the POC notebook. It's just that when you're working in industry, those are reused components that I'll reuse. But I'm trying to teach something in a linear fashion because that's the best I can do asynchronously, but it's really a cyclical fashion. And there's so many assets that are dynamic. So yeah, that's kind of machine learning in production is almost the opposite of pure ML, where it was something that was model centric is almost model agnostic now. It's everything else centric, data centric, pipeline centric, workflow centric, product centric. We start with product, right? That's the first thing to start with. But yeah, I think that's a good revelation. Model centric versus now model agnostic.
Yeah,
which is that's how I would separate it.
I love that, and that actually dovetails really nicely with where I wanted to go next, which was, I mean, we talked about PyData, for example, where a lot of the education systems, or the Tidyverse, right? A lot of education systems around this teach some ways of thinking, but they're also dedicated to teaching APIs and get people up and running as quickly as possible with scikit-learn or TensorFlow or whatever it is, right? But compared to learning these types of APIs, there are just so many moving parts to working with machine learning in production. So how did you even think about getting started, and how would you encourage other people to think about it?
Yeah, I'll start by saying that I think no one has really figured this out yet, how to teach this stuff. And I mean, even for me, the last 8 months of work that I've done with several other companies, I have like a big to-do list of updates, which I'm planning to do this month, actually. So just for people watching.
Great.
And at the end, I'll share a few other resources as well, including I think our next speaker has a great resource on this as well. But for me, the answer has always been project-based. You can never look at these things in isolation when you first start out. If you just quickly jump the gun and look at something very complicated like feature stores, you're going to be very overwhelmed because you don't know, what is this replacing? Like what are the workflows that this is making better or simpler? And then what exactly are the benefits or disadvantages I'm getting from this? You won't have that the decision-making mindset, the ability to zoom out from a specific tool and say, this is actually what it's doing, if you just start jumping into tools. So when you start a project, and it's better to start something simple, where you're not changing too many things. So the model bit, maybe we'll keep that super simple. In fact, I even try to make it a plug and play type of model. If you want an if then model, sure, keep that. If you want the latest and greatest, sure, you can swap that out as whatever you need. And then we'll try to keep the data somewhat fixed as well. But keeping those two things fixed, trying to develop a project, and really starting from the product side of things, and then going down in terms of the maturity levels. So the way I broke down the course, actually, and I think this will stay the same, is this slow increase in maturity. So first, you mentioned doing data science in the local computer, right, in the notebook. So I do that first, actually. And even for that, you want to think about what is the bottom line impact. Then what exactly do I want to do in this notebook? If I'm doing a POC, what is my objective? What am I trying to test? And then after you have this POC, then you want to think about the next layers of complexity. And even some of the companies that I worked with, many of them are at the POC level. What they see a lot of times is that, they see this, level 3, level 4 infrastructure from Google, and they'll try to kind of not copy it because it's very complicated, but be discouraged by it because they think it's either this POC where I'm doing handoffs and it's not very clean, or it's the super complicated monolithic thing I need to run on this thing called K8s. But that's not true, right? There's this path, this journey that you need to motivate yourself for why certain things are done a certain way. And eventually, if you need it, you will maybe perhaps use that complicated structure. But for, I think 90% of the people that I end up talking to that I see online, that's not the type of scale of maturity that you'll need. I know the next talk is on this, so we don't need to go into too much detail on that. But
exactly, and I will actually just share the link to that, and maybe we'll dive a bit deeper later. But I'm going to share this in the chat, everyone. Our next Fireside chat is with a fascinating human and data expert, Jacopo Tagliabue, and it's on reasonable scale machine learning. And the premise is that you're not Google, and that's totally okay. And let's figure out how we can get ROI on all the projects you need to do using machine learning. And it may not involve Kubernetes, but we're gonna dive into that in the next one. So I thought to share that in.
A fantastic resource, by the way. I talked to Jacopo a couple of weeks ago, and I thanked him for creating it because I think it's a myth that needs to be broken down, that it's either this completely unruly thing or this super heavy overhead, and it's not true at all for most people. So I'll be tuning into that talk as well. But just expanding a little bit more on this topic for how to get started. So if you're not jumping into tools and it's project based, your goal should be to learn everything from the first principles. So why are we doing certain things? How are things done currently? What are my tooling options? And then actually get hands-on a little bit. And I'll talk about the hands-on bit in just a second, but this first part is super crucial because when you're doing a project, let's say you're doing it at work or you're doing a project at home, these stacks are going to look so different. So many times you don't have control of the stack at work, right? There's some legacy system, or there's I've advised a couple of health companies now. They have a stack from day one before even getting the first hire because of certain regulatory concerns, or it's just what the CTO is already familiar with. They've signed the licenses for it. So you don't have control of the stack. So if you try to become a specialist with just a certain tool and you really learn all the functions and calls, that's really going to break apart the moment your context changes, even in the slightest. So it's really important to learn first principles, why certain things are done a certain way, how to approach this, so that later on you can adapt to anything. It's all syntax. Once you know these things, you can adapt in a few days or even less. And certainly when you have to make decisions, comparing different options, different platforms, different tooling things, you'll know the right questions to ask along the way. So that's kind of the reason to focus on this from a project standpoint. That would definitely be my number one recommendation there. And then in terms of specific tooling, if you're already working somewhere that has a certain stack, that could be that's the stack that you get familiar with. That's the one that you end up using with this foundation. But if you don't have something, then you really have to look at your context. And I think of it like a tree. If this foundation is the seed, think about all the different branches or roots rather, right, that grow out of this. Depending on the context, your stack will look a certain way. Depending on the context later or certain needs, your stack will look a certain different way. So it's really important to understand the whole thing first and then go down very specific stacks and become specialized in that.
I totally agree. And one challenge when people ask me how do I kind of get involved in machine learning in production, this is advice I know a lot of people in the space give, but it's to get one of the toughest things is getting the first opportunity and finding that at work, for example, getting a project where you can start sink your teeth into it. So there's a tension here, but it isn't like you can do a leaderboard style competition and learn. You can learn about scikit-learn and PyTorch that way, but how do you learn about in production? So there's a tension between being able to even do this when you don't necessarily have the opportunities. So do you have any advice for people who, let's say they're not doing it on the job, but how they can get started in their own life?
It's hard. And I think, efforts like Made with ML and Jacopo's repo, there's actually only a handful that I can name, right? That even attempt at doing this. And it's because it's difficult and it's because of those dynamic assets that I mentioned. We can start in the it's not the beginning is the product, but after you've motivated things and you're thinking about even the data source, right? Let's say you need to fetch data not from a single file, but maybe it's from a warehouse or a database. Learning how to interact with these systems is a huge endeavor in and of its own. So what do you do here? Do you set that up on your own? Okay, sure. If you want to set up a database, sure, where can I go? Maybe I'll do something on Roku, DigitalOcean, a warehouse, sure. Maybe Snowflake. Oh, but Snowflake only has a trial license that I can only have up for a little bit. It's so complicated to set these things up. So at least so far, the way I've been thinking about it is you can learn those tool specific things when the context arises. So let's say your company eventually migrates to Delta Lake or something, right? You can learn the specific syntaxes to interact with how to, ingest the data, how to, attach tests on top of the ingested data, et cetera. But for now, let's try to do as much as we can on the local computer so far, right? So it's important to learn about these different, infrastructures and how to, push and pull to these things, but then assume that you have a certain kind of entity coming from this, and then let's continue to work from there. So that's kind of the approach that I've taken so far, version 1. The version 2 that I want to get to, this year, as I have some time, is to expand on that. So again, the foundation has been set. Now let's actually use some of these tools. And this is the hard part, which becomes hard to replicate at home. But I'm starting to get a lot of these companies involved who are providing these things to have this educational layer, so it becomes easier to set up. It doesn't become something that I'm just drowning money on just to have an instance set up or something, sort of a sandbox, if you will. But those dynamic assets are very hard, especially on the data and compute side of things. I think those will change over time, and our efforts will hopefully pave the way for that. But yeah, that part is difficult, which is why I highly recommend that if you are someone who's looking to learn this, you do join a company that is going to motivate you to learn this stuff. So I have different advices. If you're a beginner, and again, I'm gonna regret saying this, but I'll put the caveat at the end. If you're a beginner, I highly recommend joining kind of a mid-size / large company, because you're not going to be in charge of the entire end-to-end stack, right? They're not going to throw that on you. You're going to be specialized. You're going to kind of learn how a specific part of the system works, and then as you build expertise, you can kind of expand from there, and you sort of become this T-shaped developer, if you will. So by doing that, you can get insight into the entire stack, so that later on in your career, when you go to a smaller company or you found your own company, you kind of know how everything works, and you have this experience to be able to build this out. But I highly recommend learning this stuff, because you have the context at work to actually need to do this. And that's one of the main reasons that I think most of the people that took the course and reached out to me are people that are working at existing companies, Fortune 500s or startups, where there is a need to do this. And I actually don't know too many people, myself included, who do this just to replicate something on a local computer and learn from it. So I think the need is key here. And I think it's there's this talk by Josh Wills from Slack. It was a quote he said at the very end of his talk: "You shouldn't be doing this for just like the pure fun of it. There's so much work that goes into this. First building it, and there's even more work in terms of maintaining it and updating it, which hopefully we'll touch on today, those topics. That this is not a trivial thing. It's a huge endeavor that needs a lot of effort. So make sure that it's worth all this effort. And then to actually learn this, you should be doing this in a scenario where you're not kind of over engineering things just to replicate some things."
Yeah, I agree with all of that. And also kind of aligning on expectations. I think there are the two poles which we see occasionally are some companies thinking, oh, we're going to adopt ML because you can do anything with it. And then at the other end, it's people like, hey, we can do things without ML, and finding, part of this, having these conversations is to find out what that space in the middle looks like. And that's actually where I'd like to move now. So firstly, I mean, you hinted at this, but congrats on how many people have become excited about and interested in Made with ML. You've got tens of thousands of people around the world who've found it incredibly useful. And I just want to, that's really inspiring, to be honest, Goku.
Thank you.
On top of that.
Yeah.
Oh, yeah. Sorry, go on.
I was just going to say, it's not kind of my full-time thing that I do now.
Yeah, I'm aware,
but
it's even more inspiring.
The amount of people, during COVID it was, so I definitely spent a lot of effort during that time, but the amount of people that still kind of reach out, and I'm just providing the basics. It's actually really on them to kind of continue that effort, and it's a whole lot easier when you have the right context at work or something to continue to expand on it. But the amount of people from different industries that reach out, it makes, I'm humbled by it, because I feel like I've gotten to very slightly touch an industry or impact it. And, as an individual, I never will have time personally myself to impact each of these industries, but that's kind of my main motivation. And it's all free for that reason, and always will be free, because I want as many people to learn this stuff, take it to your field, and accelerate whatever it is that you're doing. Because I always feel this education layer should not be behind closed doors.
Absolutely. And it is, I mean, the education layer is as important as every other layer as well, particularly in this space, I think.
Yeah. A really quick note on that I had dinner with Seven, one of the co-founders at Outerbounds a couple of months ago, and we were talking about this. There's too many companies in the field now, in the landscape, that just come in and throw something super sophisticated out there, when the reality is more than 90% of the application builders who are, your potential customers, are not at that stage yet. So there's this huge onus on, I would say, 100% of the tooling and platform companies to be a part of the educational efforts, to get people to learn and think about these things and get to that stage where their tool or product makes sense. I think there's a big disconnect there, and people are wondering, is the space too small, or enough people not doing this? No, it's just, they're just not at that stage yet. And You really have to you have to be part of this movement to get them there.
Very much so.
And it could be on a client by client basis or something open. That's not the main point, but focusing on that is key.
And look at the packages that have, for example, and frameworks that have garnered serious adoption. I mean, Scikit-learn is one of my favorite examples. And look at the education they've built around of it. A lot of the time they practice documentation-driven development where they write the docs first. And I think these types of things, PyTorch has taken off in a serious way the past several years, right? And a huge part of that is due to their investment in the wisdom layer.
Yes.
I think.
100%.
So Made with ML, we were just talking about how a lot of individuals have found it incredibly impactful. I think there's a tension between enabling individuals, data scientists and learners, to have access to everything they need to build stuff in production, and then enabling organizations to as well. These are perhaps quite different concerns that maybe are correlated in some ways. But I'd love your insight into, I mean, you've worked with a bunch of Fortune 500 companies, among others, on machine learning in production. So before we get into education there, I'm just wondering what the distribution of machine learning maturity in these organizations even looks like.
Okay. I will say I'm mostly shocked. And I've been wrong about a couple things too. I thought, being in this privileged area of Silicon Valley, everyone follows very mature techniques and methods across the board. Even here, or across different tech silos, if you will. The maturity, there's vast diversity in maturity. So that was something very shocking to me. Let's see, maybe I can start off with like highlights and then the reasons as to why.
Yeah.
I'd done a poll. So I teach mostly to specifically the machine learning teams within these larger orgs. And the maturity, first of all, I want to point out, is not specific to the market cap. Or the company's market cap, right? It's whether it's a big, it's a machine learning team at a very big public, billion-dollar company, or a machine learning team, that's starting from scratch or their startup. They all have issues and are all, kind of somewhat low in terms of maturity levels for how they're thinking about things. And I've thought about kind of why we have this. Because you would think a company with bigger resources, they can just get things moving very quickly and have these mature at scale systems built out that they really shouldn't be struggling with this. But it's this mindset around machine learning is the reason for this. So maybe I'll start with how things looked when I first started this 2 years ago, and then maybe some good news as to how things are changing now. But you'd see things where one good thing that I have seen in the last 2 years is where machine learning is applied. I think there's a better understanding globally in terms of where is it justified. And I think that has a large part to do with a lot of the resources that have come out in the last couple of years, around where is ML justified. I know a lot of folks from like fast AI community, things like that, where they've developed this understanding of where is this really needed and where is this effort actually justified. So that's been a silver lining. That's been some good news there. But in terms of how things are executed, it's a very individualized mindset, I would say. And maybe we can paint a picture. So there's a company that has this idea. They want to do a POC first. So they'll put usually 1, but sometimes 1 to 3 data scientists on it. And everyone's kind of working in their silos. So more than 90% of the teams that I work with do not employ experiment tracking or any kind of management around their experiments. And if you dive into it, it's not because they don't know what it is. It's because they didn't see the value of it. And it's because they're individuals who are developing these models. And then what's happening to these assets? Okay, model is trained on this version of the data set, an asset is created, and that asset is often handed off to a DevOps or an SRE team to deploy it. And the deployment part just looks like, wrapping a little API around it, and perhaps they'll throttle it, scale it as necessary. But the moment this breaks apart is anytime you want to update something, anytime you want to look at what performance looks like, if it's diminishing, you can't do this because of this physical handoff that happened. There's no reproducibility around this. If there's issues around it, you're going to probably restart what you did and hopefully you can figure out what happened. But because of this ad hoc process, there's pretty much no updates, and oftentimes trust basically evaporates, whether it's internal users that are using your application or external. trust evaporates, and the people who built this, the initial version, are off to their next project that probably will follow a similar thing. And I think this stems from kind of the processes of software 1.0, where they were building something deterministic, and it's passed on to a site reliability team who just has to manage, making sure it's up. And if there are errors, it's very obvious, like what it can handle, what it can't, and what should be produced. But this kind of handoff, I feel right now, we're not ready for in the machine learning world. And this is what I was talking about in terms of more effort to maintain what's happening around monitoring, around evaluation, offline, online, and definitely post-production as well. But yeah, that's kind of, I think this mindset is starting to change. And I think these resources are helping push that. But that's, I think, a large majority, we're still in that mindset. And because, there's trust evaporating and there's all these not so great results coming out of it, a lot of folks are not open to kind of investing time into the space. But again, this is changing. And now a lot of people do know kind of the right way to do it. But now they see that juxtaposition of, this is what I have and this is what I should be having. They see the Google example, but no, there's all this journey in between that you should be going through. So that's something that I've seen. Besides these things, I think as a whole, in terms of education, again, coming back into that, like so if this is the state of things, how are companies working to educate people on this? The really good examples that I've seen are companies that are starting from scratch, where they kind of are able to learn together. And more importantly, they're documenting what the process, so that when team members come in later on, they're able to follow through the thinking, and they're able to catch up to why the current state of the system looks the way it is, and they're able to continue. So documentation has been key here. But for a lot of companies that are out there that do have some systems available and are a little bit rigid, I don't see a lot of this education happening. And honestly, there aren't too many resources out there either to be able to do this. So I think that's something that's going to have to change in terms of in the corporate side of things, educating the current teams to how you should think about these things. Yeah, and I think we're just getting started with that too.
Absolutely. And I think you identified several key points in there, but one in particular, I think is, our friend and colleague, Ville Toulos, who's the CEO of Outerbounds and works on Metaflow and worked on it at Netflix. And I wrote an essay last year about the differences between MLOps and DevOps and why we even need this new term, MLOps. And we really focused on the introduction of real world data into software systems. It isn't really just machine learning, in all honesty. It's software powered by data is essentially what we're talking about. And when you introduce the entropy and complexity of the real world, what changes there, right? And we see the convergence of a lot of data-centric programming, literate programming with DevOps and figuring out what that looks like. The other thing that you kind of hinted at several times in there, which I think is a nice way to think about kind of a necessary condition for machine learning in production. You spoke about reproducibility, documentation. Hidden below these things is a bus factor of more than one, right? So essentially, when we want to put something in production, we want to make sure, so once again, this is necessary, but not necessarily sufficient, that if I build something in production, I can close my laptop and go to Barbados for a week and it's chill in the organization, right? Which a lot of the time we don't even have.
Absolutely. Right. I think it was Andre Karpathy in the last Tesla talk. They had a metric for days you can go on vacation and leave your ML system alone. And right now it might be 0 days or something. Not a Tesla, maybe in most areas. But yeah, the goal is we want to get to that stage where we could put something into production, go to vacation, because you have the appropriate workflows in place. Ingesting new tested data, being able to retrain your model, have it run through an evaluation pipeline, passes all the checks that you've built on over time, so that the iteration needs to happen faster and with fewer handoffs, but with more trust around it because you've attached the right tests and workflows around it. But yeah, eventually we want to get to the stage where you could go to vacation and have it just kind of show you, hey, I've updated and here's all the metadata around it that's relevant for why I updated it. But we're not there yet. And I think it's definitely contextual. That process looks different for every kind of industry and even data modality. I try to focus on even keeping that agnostic, but then when you get into specifics, you need to think about how to specifically do that in your context. But yeah, I think that is the goal, but we're definitely not there yet.
And I feel like in many places, the number of days you can take off while to keep machine learning in production is probably less than 0 as well.
Yeah.
To be honest.
Right there.
Awesome. So I would love to get into maybe some practical advice for people out there. We've been talking around that, one way to frame what we need here is drawing a bridge and connections and between laptop data science and what happens, quote unquote, data science on your laptop and what happens in industry. I feel like it's more like we need a bridge. We more like have an Indiana Jones leap of faith that we have to do at the moment, right? But for people who've done a bunch of stuff locally and maybe start thinking about putting things in production, what are the top 3 to 5 things that you'd encourage them to learn and think about when going down this path?
Okay, I'll focus on the technical side of things. So I think Hillary covered a lot of the product side of things, which people should check out for sure, by the way.
Absolutely.
I think first, starting with the data, you should have familiarity on how to not necessarily set up, because hopefully, you have a data engineering team or some admins that have originally set up the infrastructure, but how to work with warehouses, databases, and these terms are growing now. There's a lake house, there's all kinds of infrastructure, but wherever the data lives, you need to learn how to work with that. And this is huge because schools still don't teach this. I have a little brother in school right now that did a program very similar to mine, and the curriculum is the same. And you don't learn how to work with data yet on day two of your work. You're most likely given, here's where the data lives. Can you go pull that and figure out what's happening, or can you go inspect it and see if we can do anything with it, or whatever it is. And people don't know how to do that. And that's really important to know how to work with where the data lives. And again, this could look different across maturities, right? Maybe it is a file, if it's super early, maybe it's a database warehouse, maybe it's already a feature store that, the team that you're going into has set up. You need to be familiar with how to do it. But again, even before all that, which is, exactly what I focus on here with ML, like what are all these things? What are all these options for infrastructure for data? How can we interact with them? And then specifically, whichever one your company ends up using, you need to figure out the specific syntax and how to deal with that stuff.
It's so important. And this is why I think your heuristic of making things project-based is so important, because it's already overwhelming to think about feature stores and metric stores and data lakes and data meshes or like data.
And this is just the data, right?
Exactly. Yeah. This is like the foundational layer. We haven't got to compute, orchestration, versioning, architecture. So I think the project-based approach, getting started in that fashion, it stops the deep anxiety that's associated with an overwhelming space, essentially.
Absolutely.
I think.
Absolutely. You just reminded me, you'll notice that couple other things that I'm going to mention right now, they're actually all software principles that we're about to say right now. They're deeply rooted in software that are applied to this context, but there's a reason they're principles that have been adhered to over the last several decades. So it's super, super important to focus on these things and to learn as much of this as you can, if you are a new grad before you're out in the market, because a lot of places expect you to know this stuff. And schools and outdated books, or if there are books, they're not going to be teaching you this stuff. The next one I would say, Hugo, is definitely the habit of testing. And I've seen this especially in grad school. I forget who, a prominent researcher in our community referred to it as like spaghetti code. Grad school students, a lot of people like to write spaghetti code. They know what needs to be done. They know what their data looks like. They just got to get this. They got to get this function going. They got to get this PyTorch function going. And at the end of the day, that's great just to like quickly experiment things. But even for published research, especially, and certainly when you're putting things in production, everything needs to be reliably tested. So that you're building this large system that's beyond the scope of what your, one brain can store and theoretically like process exactly all the inputs and outputs. How can you trust this larger system if you can't trust the constituents that make it? So it's really important to get into this habit of testing everything that you do. And people that come from software or learn about testing from the software perspective are familiar with testing code, which is great. But there's also the concept of testing the data that's incoming and testing the data, not just at the very beginning, but perhaps at the intermediate levels as well. And then also testing your model itself, which, obviously has a lot of ties with evaluation. And a lot of the work that you do here could actually be used for the monitoring side of things too, which is kind of, the online version of things that you're testing for, if you will, and then some more. But yeah, the concept of testing is so crucial, and people think it doesn't apply to them because that's software 1.0. That's not really PyTest knows that's not really for me, but no, testing data models are super important. And it looks different. It looks different for this context. So that's actually, I look at like stats for which lessons people are most interested in, things like that. Testing is one of the biggest, because I think it's severely undercovered for how to do this. I think just in the last year and a half, we actually finally have organized packages that really enable this. Before this, people were trying to use software 1.0 options to try to do it here, but now we have good packages, great expectation, deep checks, etc., DQ, to do this for us, which I see a lot, by the way, people trying to adapt software 1.0 solutions to do something for this context and data modality. While the concept follows through, once you start to apply it to this probabilistic scenario, you can't use it exactly as it is. Monitoring is another one. Like, I remember at Apple, we try to glue together Prometheus, Grafana on top of a stack to try to monitor things. It's great for, floats, but the moment we start working with text or images and then want to monitor things beyond just these floats, those kinds of solutions fall apart, and, especially like high cardinality and things like that. So absolutely. I think it's amazing that we have these options now that are created with the same principles of 1.0, but for this context. And
I do want to zoom into that, because I mentioned earlier we have a very long tradition of data-centric programming, particularly in notebooks. I mean, going back to like Mathematica notebooks and literate programming, right? And then all these software principles on the other side. And what happens when they meet? And something I'm hearing here that I really like is we're bringing in testing principles, but we want those automated testing principles to really, I suppose, reflect the scientist's approach from the other, like the types of things we all did in notebooks. Maybe not in an automated sense when we were trying to import data, ingest data, like pandas read CSV, right? And then the types of things we did there to make sure it's what we thought. The types of things scientists did in lab notebooks when they, glue their PCRs in or whatever and start writing notes and making sure that everything is what you think it is or what you expect, right?
Yeah. Oh, absolutely. I wasn't sure if we're going to talk about this today. Larger topic, but this is why I love open source work. For example, all the companies or packages that I mentioned just for testing ML, they're all open source. All their code is tested. And in the beginning, even myself, I was like, why would I use this? I already have my few tests. But over time, my context changes, my scale changes. I want to be able to use this community built package that covers what I need now and then some more, and add, I'll contribute to it, vice versa, and it's all tested and trusted, which is what you want to do for your own code as well. But yeah, I love that comparison that you made. It's software 1.0 with how scientists think, and then joining that and creating something that's very reliable.
Awesome. So what next? What are a few more things?
I'll definitely workflows is a thing. I think this might be one of the biggest. I think this is why we originally started talking, right, with the Outerbounds team. But when people are working in notebooks, they're kind of in their head. It's kind of this. It's sure there's many functions and classes and cells that you're working in, but it's in my head and a lot of people's heads, it's a monolithic thing that they built in this notebook. I've done, processed my data, put into this model, evaluated it, and I see the performance. And then maybe I'll move these assets and put a fast API or Flask API around it. But in industry, I think maybe with the exception of a few companies like Netflix and a few others, most people don't think about like this monolithic thing, right? Or definitely can't directly translate the notebook into production right away. So the idea of separating these things into workflows is super important. Something that you did in one cell very quickly, let's say like downloading the data or maybe updating the data, whatever it is, actually warrants itself to be its own workflow, because there's in production, that's so much more dynamic now. If there's new data coming in, can you trust it? How do you use this? Where does it go next? And this idea of separating things and thinking about things in a workflow is foreign to a lot of people because there hasn't been a need to do that. But in industry and in production, that's everything. And again, going back to going on vacation, if you don't have things set up in workflows like this that can each scale on their own and each consume things and produce things and each be tested, then you can't have a holistic thing that runs on all those workflows. But yeah, the concept of workflows is definitely missing.
And I think this does also speak to some other software engineering best practices, like refactoring your code, right? So when we're working in Metaflow, for example, where we write DAGs and directed acyclic graphs, writing the steps in them in particular is trying to decouple. You start writing them and suddenly you're trying to tame complexity because they get pretty long, right? So then beginning to decouple your execution logic from your business logic or machine learning logic, right? And starting to refactor certain things there so that your DAGs are essentially more readable as well, right? And making sure that reflects your mental model of your workflow also.
Absolutely, right. And I'm sure you guys, I know you have a lot of resources on this stuff already, but I love the way how Metaflow allows you to separate things, even down to dependencies, right? For a specific function, you need a different version, whatever it is. The ability to control things at that granular level and think about things in workflows that way is super important. And you don't see that out there, right? And that's actually, I would argue, maybe the one or number two cause of so many issues. It's like, I have this conflict or this doesn't work with that. And if you can isolate things and think about it this way, it's clean. It's clean for your sanity. But it's a really good way to organize things. Well,
I very much appreciate that. And particularly, my heart rate just went up when you mentioned dependency management. I think this is still a story that we're all actively working on. I've got, different, this is, I wake up in cold sweats wondering about, what version of TensorFlow I have in a particular
I believe you.
Environment. It's brutal, man.
I try to control as much as I can, but a lot of the things I put on Colab, because it's great. People get a GPU, they run it on there. There are some periods where nothing has changed. I have been away completely. Code has not changed. I come back a couple months later. Dependencies have changed internally. There's some conflicts now, and things that ran over and over don't pass like the third cell now. And it's so frustrating. But yeah, that's why in the lessons we quickly move away from these environments that you can't manage to scripts and conflicts that you can fully manage and control. But even then there are some issues, but absolutely. It's better.
You mentioned the term spaghetti code before. We also have the term dependency hell for very good reasons. The other thing, occasionally this happened a couple of weeks ago, something wasn't working in my environment and I just rebooted my computer, didn't change anything else. And then it worked. And I was like, seriously, like what? I joke. I've been to the Genius Bar at the Apple Store maybe 10 times in my life, and 8 of those 10 times they'll just restart it and see if it works, and it did. And I'm like, that's the state of genius in modern society.
I have 2 more things. We're actually at the end of time, are we?
But that's okay. If you're happy going over a bit, everyone seems really excited and engaged. So I'd love to go over 10 minutes or so, if that's okay.
Sure. I like I said, I think we could do hours on this stuff. I'll very quickly touch on a couple more things that I had in mind. I think evaluation is a big one, and this goes to people who come from software, but certainly people in ML now. This is everything, right? Being able to trust what you've built from the workflow point of view, but certainly from the evaluation point of view, like how are we doing? And I think as a whole that I've seen in industry, and I forgot to mention this earlier, as a whole in the industry, it's still very much at a course level. And even the best companies that I worked with will have only like a fine grain level at, if it's a categorical thing at the class level or something like that. Where I'm seeing the cream of the cream and where people are able to make actionable decisions based on even finer grained evaluation are the folks that are thinking about, not just using the features that are explicit in terms of how to slice it, right? So if I have classes, maybe I'm slicing by the classes themselves, but by the implicit features. And this could be, your top clients, your sources of bias that you're trying to do, based on maybe age, race, whatever it is, but creating slices that are contextual and unique to your business that you need to watch out for, and then continuing to add to those repository of slices, if you will, over time as you are, as your systems are put into production. But evaluation, again, this has these deep roots with testing and monitoring as well. But
absolutely,
evaluation is key. That lesson is probably one of the longest on Made with ML, so I implore people to check that one out. I think those are my last one. I would say was going to be around problem scoping itself. And largely around labeling, but I think maybe we'll save that for another time. But there's, even in my last company, we didn't use labels we were given just because that's how things were done before. We looked at the signal, we looked at what needs to be done now, and it requires a little bit of forward thinking. Is this a hierarchy? Should I have hierarchical labels? Do I have the right signals to actually map to these labels? What if I want to add new classes later? What if I want to remove classes later? How do I create a system, and how do I architect it now so I can adapt to these changes later? Especially if external users are using these. Suddenly their class changes or their class disappears. Like, what implications does that have? And this, again, I think ties a lot to the product and problem scoping aspect of things. But these are just a few of the things that people need to be thinking about.
Very much so. And maybe it would be nice to just zoom into labeling very quickly. And I love your opinions on this. I feel like labeling's at such a nascent stage, and we still rely so much on hand labels. Even think about, scale AI has pivoted in certain senses recently, but they built a very serious business around hand labeling. There's a joke that they called it scale, and they built it around hand labeling initially. I think, but there are a lot of other techniques that are available that I don't think we've found a way to adopt, and a lot of open source packages and companies supporting them as well. But we are behind the curve in different ways of thinking about helping machines to label stuff and having humans in the loop in the most productive manner there, I think.
I think as a whole, as an industry, it's a harder problem than originally thought. The landscape itself 3 years ago, I remember reading many articles saying, hey, we're doing it with human labelers now. In time, we'll build models to replace all of these folks. And that's not what's happened at all, right? It's very difficult to do that. And it requires an entirely different school of thought to be able to do this. At best, you can have models in the loop to make this a little bit better and easier. But I think that's such a big space now too. And I love the amount of effort that's going in there around active learning. There's a great package called Clean Lab now from some folks from MIT I have all this and ensure it's labeled. How much of it is actually can I trust? Which ones are kind of messy or mislabeled? Being able to identify these things. It's all about, at the end of the day, not eradicating time completely spent on this stuff, but how can we focus the limited time that we have on doing certain things? And let's focus in terms of what should I label, but also like in terms of, how do I make this faster, better, and how do I make this a workflow eventually so that I can get this done? Because a lot of scenarios don't have natural labels where, the thing that happened is the label, for example, in time series or something. How do we bake this into a workflow? How do we trust what's coming out of there? Overlap across labelers, et cetera. So there's a lot happening here, which is great to see, but it's going to be a while before we just have this wrapped up as a workflow ready to go.
And I mean, you mentioned active learning, but we also got forms of semi-supervised learning, weak supervision, transfer learning, synthetic data generation for computer vision. I'm fascinated by. There's a lot of action there. The other thing, part of me hesitates to go here, but I think we're at the tail end where, we can start riffing on a kind of slightly tangential things. And I know this is a very deep interest to you. I'm going to give the example of what hand labeling, the hand labeling industry, and the labor market, I think there are deep ethical concerns there that we need to interact with more. Now, I don't necessarily want to talk about that with you, but what I do want to kind of get your thoughts on, because I know you think deeply about this, is the potential harms done by machine learning, and kind of trying to figure out what machine learning. I hesitate to use the term ethical because I think there are normative constraints there, which I'm not entirely comfortable with. But let's say machine learning, which serves all the people who are stakeholders in it, and perhaps doesn't do harm. How we can think about that for practitioners and end users and consumers of machine learning products. I know that we could talk about that for 24 hours, right? But
yeah, maybe I'll talk about a very specific aspect of that larger topic. I think a lot of it has to do with the intention of the team that's building these systems, right? They need to be very intentional about thinking about what does it take to, even from like the labeling side, right? Like what does this effort look like? Who are we using to do this? What does their experience look like? And then every step of the way, when we put this into production, who's using it? How is that designed? Are the model's outputs directly shown to the consumer? Who is the consumer, first of all? Is it directly shown to them? Is there another layer of filtering that's applied to them? When something goes wrong, how do we know like who's to blame, or even more important, who needs to actually take ownership and fix this thing? There's so much intentional thinking and decision making that goes into this. It's a big question, Hugo, right? To be able to think about this stuff. And just to add one more thing, so much of this could be way down the line.
Yes.
You know, I'm deep into the genomics side of things right now, using machine learning for genomics and biologics and small molecule design. A lot of the things that are being developed right now, in terms of implications, could be decades later, right? In terms of what's happening, who's responsible for this, and being able to attach an event that occurred to something that's being thought out, fleshed out right now. I think it takes a lot of forward thinking, and this is why one aspect of the solution to this is the need to have so many different personas in the room, not just developers who can build the system in the room. When you're initially planning this out, you need to have be it policymakers, the physicians, the subject matter experts in the room when this is being thought out. And I don't see many teams doing that, because it takes a lot of effort to get these people together and think about this stuff. But that is one of the best things we could do to thwart problems, because these people have the sort of the foresight to see what could happen and how we should design things. But absolutely, it's a huge topic. And I think there's even collections and repositories of like ML fails, and each one of these we could break down and see exactly what happened. And there's a lot of finger pointing that happens, right? We saw this with the Zillow use case. Absolutely.
And you actually mentioned Fast AI earlier. For people interested in this type of things, the Fast AI blog has some beautiful and thoughtful pieces on this type of stuff by Rachel Thomas and Jeremy Howard, and Rachel's work in particular is super inspiring. I love that you mentioned intention, because I think what you're trying to build, because of course, if you're building something and optimizing for engagement, that's going to have downstream effects on all types of stuff, right? Yeah. If you want people to engage as much as possible, as opposed to, Facebook, right? They decided, and I don't know the details of this, they decided not only to focus on time on Facebook, but time well spent, quote unquote, whatever. Of course, I think one of the huge dangers is that the things that are really good for us in some ways seem to be most evasive to measurement as well. So when we're building scalable,
no, that's true, right? It's hard to measure that stuff. You also need to think about who's coming up with these things that are to be measured. Like the company that's building the thing to make the money off of it should not, I think my view, should not be the one that's coming up with this noble metric that's going to measure how they're doing.
Yeah. And particularly if they're entering the commons, there is an argument that these networks publics they're not just private corporations who, because about the systems we built can operate in any way they want, they have become the town square. And I think we need different mental models and different accountability for
yeah. Oh, this could be really interesting for another day, but I am starting to see kind of pillars, at least in the health field, where if you're a company that's promising, promising a product with certain functionality in a space of certain performance, there are pillars that are coming, third-party pillars that are coming to evaluate what this could look like. And the FDA is one layer, eventual layer, but we want to be able to catch things at a more fine-grained level that maybe will take longer for the government to adapt and things like that. But I'd like to see more of these pillars. And it's not about bureaucracy. It's about something that perhaps industry-wide is adopted, that everyone agrees that we need to all pass these kinds of checks and tests that happen periodically, because these systems, keep changing, they're in flux. But I like this kind of movement, but it needs to be done right, because we don't want more kind of red tape on everything, because that staggers innovation. But we don't also want free form things to just happen untested.
Yeah. And I think initiatives such as model cards and this type of stuff really help us go down this path. And I don't think this is quite the right model, but we've got like nutritional information on cereal and stuff in supermarkets. So just imagine whenever you're interacting with a model. Now, I don't think this is fantasy in some ways, but it's interesting to think through whenever you interact with a model, having some information as to what's actually happening there. Because something we don't talk about enough, I think, are probably like machine learning dark patterns, right? In the same way we think about, front end dark patterns and that type of stuff. The other thing you mentioned, which is key, is diversity in the room. And I think one of the probably most uncontroversial examples here, well, having said that, what's uncontroversial these days, but is when Twitter started, right? They had a character limit for usernames, right? And as it turns out, that reflected the types of usernames the founding members and early employees who were predominantly white had, but it didn't reflect the possibility of a lot of other names around the globe from different cultures, which
great example,
which are longer, right? So
yeah, absolutely. All you needed was one person with a longer name in the room, and
exactly.
But could have been
we could do this. This is so much fun, man. We could do this for really so long. And we'll have to get back to it again at some point. But I'd love to just give you the space. I'd love to hear what you're focused on now and what you're excited about now.
Yeah, definitely want to share this in case listeners are interested in this space. I want more people to apply this to, let's call it previously low throughput / previously ignored industries. So as I mentioned, my background's in biology and chemistry, and I've developed some expertise in application of machine learning and dealing with data, and I want to take it back to that space. I've worked in the clinical informatics space, but in my head, I kind of think about that as sensor generated / human generated, like precision oncology generated data. Whereas to me, biology genomics is more like, pure nature science generated. And it's really evolved from a low throughput to a high throughput field in the last half a decade. And it's continuing to get even bigger and better, where, we have even entire like cloud labs where things that were previously, I used to do almost a decade ago, things that I would have to do with a pipette and manually observe and, arduously do over a period of a week are done quicker and automatically, where I'm still designing the experiments initially and things are happening. And then eventually even the experiments themselves are being auto-designed based on some objective that I'm trying to solve. So these kind of waterfalls are being kind of unblocked here. And specifically what I'm working on right now is just because, again, not to force ML on everything, but because of the modality of the space, with drug discovery and small molecule design, ML is already being very well leveraged, and it just makes sense for this space. So yeah, I've been kind of been heads down on looking at applications, and I like research, but I've always been a product guy. So I'm trying to figure out the specific kind of aspect and problem to solve right now with some couple of folks. And I'm actually leaning towards some nonprofit efforts actually as well, because I think while the data bottlenecks are removed, there's still a little bit of work that's needed before we can start to have full-fledged products. And the mRNA that's in most of us today, most of our listeners, I'm sure as well, is there so quickly because we needed that. But all future work that is in that vein needs to be so well thought out. And we could talk about risk in this space forever, because there's so many downstream implications. But in my head, I'll leave with the summary. In the last many decades, we've been putting code into hardware, silicon. I think the reason I'm so interested in this space, and I'm getting deep, is I think the next perhaps century will be about putting the same code, the concept of code, but inside wetware. That could be at the plasmid layer to design proteins, to design enzymes, to do certain things. And I thought, this may sound like science fiction, but there's already organized packages to be able to control things at these granularities. And it's super exciting. It's also super scary as well, because we need to do this again very responsibly and methodologically, but
of course,
super interesting to be alive even at this period in time.
Is there an argument though that even though that does sound futuristic in a lot of ways, that we do this in some ways with pharmaceuticals and a lot of other things already, not quite altering genetic code per se, but definitely altering our physiological makeup with stuff made in laboratories?
Oh, absolutely. I think the big change that's coming is the process itself.
Yep.
So initially, by the way, compounds are used everywhere, right? Pharma, energy, material science. Yep. And so far, it's been about leveraging naturally occurring molecules and compounds. And then certainly the design process to break apart from that, the build, test, and design process is super complicated, super arduous. And this is where ML comes in to help navigate and and kind of shrink that space. But yeah, it's absolutely happening. Actually, if you big examples that people don't immediately tie onto this are around synthetic biology, like Beyond Meat or Impossible Foods, right? Yep. These are companies that are working around the clock to make it cheaper, better, by engineering things at a more primitive level to make it more X-like. Yep. But yeah, it's all around us, and it's biology for everything, if I'd say it that way. So it's not biology for medicine, it's biology for everything. Biology for everything. And it's actually called tech bio now, kind of a tech-enabled bio. So yeah,
what's the difference between that and biotech?
It's kind of flipped. So it's before it used to, focus is always on biology, by the way. That's the kind of the foundation of it. But now it's about how do you develop innovations that really leverage technology to solve bottlenecks and things like that are innately part of the biology aspect. It's also a marketing ploy by many different companies, but yeah, tech bio is being kind of the adopted term.
That's great. I love it. And I love that you mentioned Beyond Meat as well, because this is a nice example of something that's now deeply in our cultural consciousness and it's being adopted at scale. I actually a while ago had like a Beyond version burger at Burger King.
Oh, I didn't know they had this there. Okay.
Yeah, so that they've really taken it on. And someone asked me how did it taste, and I said it tasted like cardboard. And they said, well, that's a great reflection of Burger King, so they've done the job correctly, I think. So, that's great, Goku. Let's wrap up now, but I just want to thank you for such a wide-ranging, thoughtful conversation. I appreciate you. And
thank you guys.
It was so much fun, and I look forward to doing this again.
Absolutely. Thanks for having me, and I'm going to be definitely tuning into the next two with Jacobo and Hamo as they kind of expand more details of everything that I talked about. Yeah. But yeah, hopefully I will get to do this in person sometime too. Have that be that
would be very exciting. And everyone who's joined today and is watching after the fact, thank you so much. It was great to have you here. There were some questions you asked. I'm going to share this link to our community Slack, and we'll be there for the next week or so for an AMA. So just in your own time, come to our AMA guest channel there. And Goku and I will be responsive. But as you can tell, we love talking about this stuff. I mean, we could go on for hours more. So we look forward to seeing you there. So thank you once again, Goku.
Awesome. Thank you so much.
And scene.
No, perfect.